Alright, you guys, so I am slowly figuring out how to use this software, especially on my Mac. I have no idea what the heck is going on half the time, but here we go. So, yesterday, I know in Earth Science, we did this. And we talked about the geologic time scale. We wrote it out for the Ozarks, and we made this pretty little picture. For environmental science, we just made the notebook. Okay, we just got this in there. Pause the video, environmental science, and I want you to flip to this first page, and I want you to write this information down for me as I go over it. If you're in environmental science, just click, or in earth science, just click forward, and I'll do my best to get everything fixed. Now, again, like me, I left all my stuff at school, so we're having to adjust. I have put a document on Google Classroom for you, as you can see on the left here. It is called the Arkansas Geologic History of Arkansas Through Time and Space. It's a very interesting read, in my personal opinion, but I can understand where it might put some of you to sleep. So what's going to end up happening is I'm going to break apart some of these things inside this document, and we're going to put it in here. I don't have the pretties to put over here. Like I said in Google Classroom, I'm not worried about the pretties. I love the pretties, but I want this information on your stuff. So I'll give pause for environmental science, pause, write this information down, and then I'm going to go over, to my next region, which is the the Arkansas River Valley, and I'm going to show you exactly where in this document and exactly what we're going to do. So, because I left that paper at school, I had to go to a bigger appendix, a bigger document. And what I want you guys to do is break down the document, page 44 through 52. That'll be in your notes. Page 44 through 52. I want each person to get a section of Arkansas and read the one-page little ditty about it. And I'll show you that in a minute. But take a look at page 5, and you can actually see how the U.S. has changed from the Cambrian into the Devonian and Mississippian, Permian, Triassic, Jurassic. So when the dinosaurs, Triassic, Jurassic, Cretaceous, and then into the Tertiary, which we're even more spread apart now. So that's just an interesting little paleogeography on page 5. If you want to go through all of this, you're more than welcome to, but page 44 is going to be your friend. So we're going to go all the way down to page 44, where it actually breaks apart the individual divisions of Arkansas and how things were made and the dates and whatnot. So you could see here, when we looked at the Ozarks, it mentioned the plateaus several times, which you could see. Here's Fayetteville, there's Eureka Springs, so they're both on the Springfield plateau. And you could see all of this information. Anything in blue is in the glossary that you can look up, but I'm going to try to do my best to help explain what's going on. So, in the Arkansas River Valley, what you're going to do, whoever gets to Arkansas River Valley, they're going to read this, and then they're going to share it with everybody. Now, my goal is not for you to sound like some crazy geologic student, okay? That's not my goal. My goal is for you to get 2 or 3 major things with some dates out of this. Now, if this is too much for you, that's fine. Scroll down. There's the Washita's. Again, very small. The Gulf Coastal Plain, very small. Mississippi Alluvial Plain. They do not include Crowley's Ridge. Look right here. If you'll go through this, it gives you times, dates, ages, periods, which is on our geologic time scale here. Okay? If you want to look at just this, you're more than welcome to identify what's going on. So for the Arkansas River Valley, we don't know much about what's going on in the Precambrian. We know that there's some weathering and erosion. So I might write Precambrian weathering, erosion. The idea is not to write everything that's on this geologic history, page 50, on your paper, okay? The idea is to get you to understand how things have changed over time. So if there's weathering and erosion in the Precambrian, that means it must be above ground somewhere. It's above water because it's weathering. But it looks like when we go into the Ordovician, we start getting slow, shallow carbonate muds, which again is that calcareous, that calcium deposit that creates limestones. We get shale, which is extremely present. Anywhere you look, we get shale. It's that black, flat rock that erodes really easily when you mess with it. We start getting quartz sand deposits. And then it says many regional unconformities. That's just where that law of law of superposition starts to occur, where things don't start laying on top of each other. Things start to fold and manipulate, and you start getting areas where they don't match that, like cake layering. So for the Ordovician, you could say, that it's a shallow sea, shallow marine area. You're going to start seeing that at some point, Arkansas floods and then doesn't flood. And it starts creating all of these layers of sandstone and shale. Sandstone, shale. There is some limestone in the river valley, not as much as the Ozark Plateaus though. So now you can see in the Devonian it gets slightly deeper. So you could see that this shallow sea is no longer shallow; it gets deep. So we know that in the Mississippian. Okay, that sea is getting deeper. Now, you don't necessarily have to write this down, but what that means is your sediments are getting smaller. You're going to have more clay deposits. You're going to have a lot less grainier sandstone. You're going to have a lot more limestone. And you're going to end up with this stuff called siliceous ooze, which is what they use whetstones out of. It's extremely popular in hot springs. There's a beautiful outcrop of it there on Highway 7 as you enter Hot Springs on the left-hand side. And it's super, super fine. And people use it to sharpen knives. We call it siliceous ooze. Because it's still quartz. It's just so thin that it doesn't have any grit to it. So now as the earth gets younger, in the Pennsylvanian, we start to have some uplift. When we start having uplift, we start getting larger sediments. So we have, limestone and clay on the bottom, then on the top, then we start getting some more sandstone. So that is in the Pennsylvanian. We start getting sandstone deposits. Due to uplift. And what this uplift is from a huge continent coming up. And think of this as not just Arkansas in general, but the United States. Coming up and pushing up this direction. And it's taking the Ouachita Mountains and forcing them up. So this area actually comes up a little bit as well, and that's where you start getting those shallower seas. Also in the Pennsylvanian, downward flexing. Here's where the two continents begin to collide, where you start getting those shales. And so on and so forth. So it's basically that, we call that the Ouachita orogeny. Orogeny just means uplift. So you've got the the Laurentide orogeny, which is the mountain building event that goes on over in the Rockies, and then you have the Ouachita one that happens here and forms our mountains, our Ouachita Mountains. But because of all that, you've got highland in the Arkansas plateaus, you've got now highland here, you're going to start seeing some weathering and erosion due to runoff of materials. So in the late Pennsylvanian, early Permian, and really throughout the rest of history, you get a lot of weathering and erosion. So from this graph, you could see from the early Permian all the way until the tertiary, which goes even past our picture here. No, it doesn't. It stops right there. Is just weathering and erosion. So from Permian on, okay, we just get weathering and erosion. Now here, this is in the last, call this a tertiary, and then we go into the quaternary. I'm sorry. The quaternary is right around here. They just don't have it on here. But the Pleistocene, you'll know, is like mammoths and all that fun stuff, and man. So at this point, it looks just like what we see it today, with lots of deposition, lots of terraces, floodplains forming, and we see some farming starting in the Holocene. So after that, or if we wanted to, you could say in the tertiary, we begin seeing deposition and human interactions. Now, if I had my pretty pictures, I would cut them out and glue them on here and, do what I wanted to do. But I don't. Now, I could make this lesson 45 minutes long, but I don't want to. So the next thing you're going to do is go to the Ouachitas, and you're going to do the same thing. As I talked through this, I really felt like this helped a lot more than the rest of it. But you're more than welcome to work through the rest of everything. So you're then going to focus on the Ouachita Mountains, which are here in green. Okay. So Ouachita mountains, and then you're just going to go through a list starting from oldest to youngest. So started that Precambrian, go all the way to the bottom. Then you're going to flip and you're going to go to the Gulf Coastal Plain. Let's see if I have any other colors. Okay, you're going to go to the Gulf Coastal Plain. Which I really think that this map makes that Gulf Coastal Plain a little bit bigger than it actually is, but I'm not one to judge. So your Gulf Coastal Plain. Now I think this is a changing marker. Yeah. Fun stuff. Okay, that way we can see it better. Okay, and again, you're going to write your information. You can do this in groups. You can do this by yourself. I don't care. The information's all there on page 51 and 52. You're then going to go to your last page and talk about the Mississippi alluvial valley, or the delta. Now, somewhere in here, it does talk about Crowley's Ridge. However, it's been obviously hot debated for a long time exactly how Crowley's Ridge got there. A lot of them say it's just sand that has blown in from ages and ages. A lot of it said it's not volcanic uplift, but uplift from the New Madrid Fault that's been there. But it's so small. Right here at its tiniest is like 1 mile. And at its largest, it's like 6 to 7 miles wide. So it's super tiny. I'm kind of surprised that they even have a region for that. But anyway, Mississippi Alluvial Valley, or the Mississippi Delta. I'm going to call it the Delta. That's where all of our rice and goodies are grown to ship across the world. Soybeans and all sorts of fun stuff. Ooh, I don't like that yellow, but here we are. Can't stop now. And I want you to write your information. There's going to be a grade on this information that you did it, okay? It's not that it's right or wrong, but all that information is there. If you don't understand something, there's a glossary. Here's different rock types that exist in the area. There's the glossary. Let me see if I can find information about Crowley's Ridge for a minute, just to show you if you want it. These come from there's nice pictures in here for each era. But you can see, there's Crowley's Ridge and there's ice. So during the Quaternary period, when we talk about, the Ice Age or the Pleistocene Ice Age, ice did come down this far. And they're saying that it could have been created by ice and then eroding the Ohio River and outwashing two rivers. So you could see that it says, here's the Mississippi River, and then here's the Ohio River, and it literally just left a ridge in the middle from that melting ice. Who knows? That would be kind of cool, though. You could see there's Louisiana, and then the Gulf of Mexico. So that's interesting if you do want to look at it. Again, this is going to be attached to Google Classroom along with this video. I hope this helps. Have fun.